On to the next talk from a man that needs no introduction.
So when I was uploading the talk this morning, we got an error saying that this presentation is corrupted. So here you go, a corrupt presentation from someone from NASA headquarters. What are the odds? Okay, so Greg asked me to talk about the SKGs and also to provide some context to the ISECG landing site. So I will do that and then talk about some other stuff that I want to talk about. So the strategic knowledge gaps, we hear these are used a lot, particularly on the exploration side. There's often a perception that they represent requirements, but as I'll talk about, there are, certainly for the lunar surface, there is no sort of level 1 SKG requirement that we need. There's no data that we need before we could plan on sending humans back to the lunar surface. I'm done. Yay. That gets us back on schedule. Thanks for that. Not enough from you. So there are two kind of SKGs that we'll talk about today because it's relevant that we can get information from some of these science lander missions that we're going to be discussing over the next 2.5 days. The key ones are probably what are the ones that buy down risks, and the analogy that I best use here is the size of the lunar module footpads. These were designed back when we didn't know what the bearing strength of the regolith was. There were people that thought it was talcum powder and people were going to land and never be seen again, or it could be solid rock. And so the lunar pads they're like camel's feet. They're much larger actually than they needed to be. So information like that would have allowed us to design smaller, lighter lunar module footpads. And then there's mission enhancing. So there's data that we could acquire, particularly that would allow us to use local resources, that it would allow us either to go for longer, stay for longer. There are 4 sets of SKGs. There's Lunar, Phobos and Deimos, Mars, and NEOs. And we now actually have a web presence. So the Lunar Science Exploration SKGs, these were last revisited and revised back in 2016. At that point, the potential architecture for humans to the moon hadn't changed in a while. So the main effort that was done here is to see which of the SKGs had closed because of the wealth of new data that we had since they'd last been looked at. And this effort was led by LEAG. There are 3 themes for the SKGs. One is to understand the lunar resource potential. One is to understand the lunar environment and its effect on human life. And one is to understand how to work and live on the lunar surface. So the reasons for these pictures, in case you're curious, is this is my dig holes, fill hills in, which is at some point we're going to want to come back to SKGs and look at them again. But I'm very conscious that we don't want to make work for the sake of it. But that said, once we start to have more clarity on how NASA is going to return to the lunar surface, then it might actually, and we have a new architecture, and if it's vastly different to the last architecture that was used, we probably are going to want to come back to these at some point and give them another look. There's a huge temptation to constantly revisit things like this, but I am also very conscious of the fact that the lunar science community is a wonderful resource, and it's important not to overuse it for the sake of using it. So the key findings from the last revisit of the SKGs was that several of you can go onto the webpage and look at this. Several of them were essentially deemed closed. One example being there was an SKG to do with polar lighting, with the topography data from Kaguya and LRO and the imaging from both those missions, that was essentially deemed closed. And there were several that were deemed closed. There are no strategic knowledge gaps that would inhibit sort of sortie, less than 28-day missions to the lunar surface. That said, there are several SKGs that should be addressed that would increase human safety not only at the moon but also in LEO, cislunar space and beyond the moon. This includes the development of infrastructure to monitor solar activity. There are numerous SKGs that would enable and enhance a more mature human exploration capabilities for the moon. And then there was a sort of a programmatic finding, which is that discovery, new frontiers, and international missions to the moon should be examined for potential additional NASA contributions to help retire SKGs. So then what I did is essentially, this shows how the SKGs are broken down, and I'm obviously not going to read all of these. What I have done is gone back and looked at them carefully and worked out which of them do I think can be addressed by adding key instruments to any lunar lander science missions of the type that we're going to discuss here. And the key takeaway is most. So this was the theme 1. These are theme 2, and again, you know, the vast majority can either be closed or certainly significantly addressed by lunar lander, small-scale lunar lander missions. And then finally, there we go. And most of the other ones are actually SKGs that require testing on Earth. So to come back briefly to, do we need to look at the SKGs again? This gives you an example of how the SKGs are sort of kept on the web page. This is one particular SKG, so it describes the theme, the category, it describes the narrative, is it enabling or enhancing, and then some prose that sort of describes in more detail measurements or missions needed to retire. And actually it was Mark Robinson, who is here, who looked at these, and he made a very interesting comment, which is, we don't put very detailed quantitative, we don't provide good quantitative details on the exact measurement that is required in order to close the SKG. And so he thinks we should certainly take a look at these, and that might be something that is worth doing in the near term, which is trying to provide better quantitative information of, because if you are planning a lunar lander mission, give people as much detail as possible on the types of data that would have to be taken in order to help close the SKG. That was not a mandate for the last group to do, but it might be something we want to do to make them better. And if Clive's nodding, I must be worried. Okay, so now staying on time. Now I want to talk a little bit about the International Space Exploration Coordination Group landing sites that have started to pop up, and I think it's very, very important to put these into a realistic context of what they actually represent and what they don't represent. And so ISECG, many of you know, it's a non-political agency coordination forum consisting of 15 space agencies. Its primary document is the Global Exploration Roadmap. Version 2 of this came out in 2013. Many of you were here at Ames in December of last year for the rollout of version 3 is expected to happen in the next couple of months. As part of GER2, there were three reference destinations, which was a deep space habitat in the lunar vicinity, the lunar surface, and near-Earth asteroids. And these were described in GER2 as potential locations that humans would go to before we went to Mars. Some aspect of ISECG, of why it exists, is to do high-level engineering studies by multiple agencies to look at what it would take to do human missions to these destinations. And with that in mind, there are 3 reference missions, and they're described here. And again, for the lunar surface one, the ISECG reference missions are the crew live in pressurized rovers. It's 5, initially 28-day missions with a crew of 4, 1 mission per year, with the rovers being driven in between landing sites, and then a year later the crew goes to wherever that rover now is. So, and again, that's a reference. That's not the agency saying this is what we're going to do, but that was the agencies describing something they thought was a realistic scope, and that allows the agencies to work together to look at how they could provide the engineering for this scale of mission working together. So one of the things when I first started to join ISECG is when this was described, it was just like that. It simply said there will be 5 missions. And so I remember asking, had any sites been chosen? And the answer was no. So I offered to come up with an example of 5 sites, not to say that, and this is key here, these are the 5 sites, but just to show how, if you, as an example, if you pick 5 sites carefully, you can actually increase the science return. And so actually Paul Spudis and I did this together. Obviously we started with the constellation sites because, as was already been mentioned earlier, this isn't the first time people have thought about this, and this seemed like a really good starting point. And so what Paul and I did is we ended up coming up with 5 sites in the South Pole Aitken region. 4 of them were constellation sites. The 5th one, Antoniadi. We had to find a 5th one within the general area, and we just sort of came up with a science rationale where each of these 5 missions was scientifically interesting, but at the same time, the 5 as a whole gave you a cross-section within the South Pole Aitken Basin, so there was increased scientific return. And then David Kring very kindly used his intern program to do really detailed studies of how the rover could drive in between these sites and to show that it's feasible. But they aren't the only sites, and JAXA has done a study where they've looked at the South Pole Aitken region from a human exploration perspective, and they have scientific justification for other locations in this region that are just as valid for places that you might want to go. And wait, don't order yet. The moon is interesting everywhere, and so Gruner and Sam Lawrence, they actually have an LPSC abstract last year where they sort of did a similar analysis, and they picked 5 sites which were not polar. And again, same rationale. Each of these missions was scientifically interesting, but they were close enough together such that you could drive the rover in between them, in between human missions. So that's just a little bit of background context of when you see these kind of maps, where it has come from. It's not saying this is where you're going to go. It's basically just showing that the moon is diversely scientifically interesting, and you can basically send humans anywhere and you're going to do good things. Okay, so the last part I want to talk about some of the other ISECG activities. Several of us in this room have worked on a science white paper whose role was to look at those 3 reference missions and basically outline high-level science that would be enabled by sending humans to these locations. And one of the ones, the only one I'm going to show the highlights from is the science enabled by humans at a deep space habitat in the lunar vicinity, which obviously now in NASA speak gets referred to as the Deep Space Gateway. And the reason for showing this is several of the things that came up from the science community that got them excited by how a gateway would enable science was lunar surface access. It was things like, could you have a reusable sample return lander such that you could have global access and bring samples back from different places? So, and also there's a lot of interesting science that could be done with low latency lunar science, telerobotics with a crew on the gateway. And so, as we've looked at this, I think in the next 2 days, as we look at different sites, I think it's interesting to think about, yes, these might be science missions, but once the gateway is there, are there ways that you could potentially design these differently, for example, reusability, such that you increase the science even more? And with that in mind, we are having a workshop next month in Denver, Colorado, the goal is to look in more detail at the science that can be done. This will cover all scientific disciplines. So we have a heliophysics, earth science, astrophysics and fundamental, lunar and planetary science, and then life sciences and space biology are all covered. We got almost 200 abstracts for this. And then we'll get cross-cutting sessions that will look at things like external payloads and telerobotics support and different orbits. And the goal, there's sort of 3 purposes to the workshop. First is to identify in more detail the high-quality science that a gateway could enable, to also start to scope out the level of instruments it would take to acquire those data, and finally, what resources would the gateway have to provide in order to conduct that science. And with that, 1 minute.
Questions for Ben?
Oh, so close.
Yeah. Hi, Ben. Just a point of clarification. On the SKG document that we assembled for you, we weren't asked to look at instrumentation and precision and accuracy.
I know, I said that. I
know you did. Yeah. But I just wanted to point you in another direction, that when we did this initially for Mike Wargo, he requested that. And so there's a document that does identify instrumentation, precision and accuracy that you could potentially use as the first step to reviewing the SKGs.
Okay, thank you.
I'll say one more time, SKG, even for 28, you need to take a new look at suits.
Okay.
Spacesuits, in terms of multiple reuse, as well as refurbishment. Maybe not for 28, but for any longer period.
So these SKGs are more from the side of what data do you get as part of doing scientific research that helps you. What you're saying is obviously totally valid, but that there are such things, if you like, as engineering SKGs that are captured elsewhere. Okay. There aren't really science missions that are good. Well, some of the dust analysis possibly that you could do. But if you're talking about suit design, that's a whole other level of SKG.
Well, but that's the basis of human science, is having a good suit.
Yep.
And a reliable one, and one that you can use multiple times. The other point I wanted to make is that you need to learn, from the resource side of your things, you need to learn how to do in situ analysis of volatile resources.
And there are several SKGs on that.
Okay, because their volatile resources are lost from the point of sampling to final analysis.
Yeah, no, that's good
due
point.
to agitation.
Yeah.
Now, I just happen to have a thought. We have at least one core, I think, that is still preserved. Two? Yeah. Oh, there you are. I was wondering if you were here, right? And those would potentially, if they've held their seal fairly well, give you some information on this agitation issue. And I just remembered that. Station 3 on our mission. And was there one from 16?
Yep.
Yeah.
Yeah. There are at least a couple of SKGs related to being allowed to do things with the sample. I think one of those is opening one of those cores.
But ultimately, you're going to want to have in situ sampling.
Yep.
And one of the ways to look at solar wind volatiles, of course, is with an orbiting gamma ray spectrometer that can sense the neutron capture of helium-3. I don't know that we're capable of doing that yet, but that anyone can design a 23 MeV gamma ray spectrometer. That's one thing you can do to get a global analysis of the distribution of solar wind volatiles.
Seeing you open the door to by talking about the Deep Space Gateway, is there anything specifically about the gateway in terms of limitations, the orbit, space considerations and things like that need to be brought out at the beginning of this meeting? Because obviously, if you're talking about getting samples up and down from the surface, if you're talking about storing samples for bring back on Orion, are there considerations that need to be borne in mind at this point?
Not for this meeting, but yes, we have a whole session on sample handling at the Gateway Workshop, and that includes how do you ingress them from outside, how do you store them, do you have to store them cryogenically? If they end up being Mars planetary samples, you've got planetary protection issues, and then you have to be able to bring them back in Orion. And the other part of it is, are there analytical things, capabilities you actually need on the Gateway, because you can't wait till they come back to Earth, you will actually lose the ability to make those measurements. So yes, Cindy Evans is leading that group that will discuss all aspects of the sample side.
Yeah, actually, I was more worried about the orbits that are under consideration for the Gateway, and whether or not that provides limitations on what part of the surface you have easiest access to.
Yeah, we have a whole session on, one of the things that we're asking as part of people's talks is going to be, what orbits do you want, or at least can you cope with? And then we actually have a whole cross-cutting session to discuss orbits as well.
Thank you, Ben.